Thank you. My co-presenter today is Amy Simonsen. Amy and I have been working together on pipeline data projects for a number of years, and the specific presentation that we're giving today is of a project that we've been working on for a number of years. So the title of it is Pipeline Data Modeling for Enterprise GIS and Introduction to the APDM. Just a couple points I'll add before we start. Like Mark said earlier, this is about specific application and specific software type product, and hopefully the main points of this will be applicable to all of you, whether you're working on pipelines or other type of applications, whether you're using ESRI products or other software products. And then to kind of echo something that Bill said earlier, the real key to all these type of projects is the integration of multiple disciplines. So that's what the Enterprise GIS is all about. It's not just engineering, it's not just land, it's not just environmental. It's helping all of those departments and all those groups work together so that they can all speak a common language. They all have the same database they can go to and get information about what's happening on their system out there, whether you're in Eastern Ohio or Western Pennsylvania, whether you're doing land work or you're doing geophysical type work. Okay, so data modeling is essentially designing the structure in which you're going to put your data. So one analogy of this is a drawer divider. So you design the boxes that hold your data. And why is that important? The more precisely you can design your boxes, the more precisely the data you can capture and how you can store it. So there's no silverware, there's no data. It's simply the design for the spaces. The actual physical drawer divider, the analogy of that would be the schema. And we'll talk more about schema later, but the schema is essentially a phase of the data modeling process. So data model, essentially it's a standard. It's a standard for data collection and storage across your entire organization. And it defines the values that you record about all the different objects that you want to store in your GIS. So you have a piece of pipe. What attributes are on your piece of pipe? How does that piece of pipe relate to other features inside your database? The definitions of those pieces of information and the relationships to other objects is all defined by the data model. So, but the data model itself is just storing information about the data. It's not a tool, and it's not actual data. Data about the data. So like I said, data modeling is part of the Enterprise GIS project, especially in National Fuels experience. The good resource of this is Roger Tomlinson's book, Thinking About GIS, and he places data modeling as the third step in an Enterprise GIS project. So this is essentially formal data modeling. And we've all done, if we're GIS professionals, we've all done some sort of data modeling. We've opened up our catalog and we've said add a new feature class or add a new table, and then we've designed attributes to put into it. Add a new field, make it a string field, make it this long, make a numeric field, make it double, or make a numeric field, make it integer. Those are all kind of informal data modeling processes where you're simply on the fly adding new features and adding new attributes. The key here is this is formal, it's a structured system, and you want the different tables and object classes in your database to be related to each other in a systematic way so that people who aren't GIS professionals can look at it and they see something that's easily understood because it's all systematic. And the key to doing this is cooperation. You have to be everybody has to cooperate to some extent to use the same database, whether they're engineers or if they're land folks or environmental. They usually in the past have had their own piece of information, whether it was an Excel table or an Access database or perhaps shape files that they maintain themselves. They would create a map, they would do what they needed to do, they would hand that map off to somebody else and they did something else. Like Jacob said, the problem with that is you can quickly get fragmented data. Hundreds and hundreds and hundreds of shape files floating around. Everybody's looking at different data. Everybody has a different perception of what actually is happening inside the organization. And if you become more centralized, more standardized, you can make the organization more efficient. So there's essentially 3 phases of a data modeling process. The first would be conceptual, and this starts out with brainstorming. You're simply creating lists of objects and attributes and how they're related to each other. So you can start this with paper, with Excel, with there's other specific types of data modeling applications you can use, but you're simply creating lists of things and capturing information. The second would be a logical modeling process. In the logical modeling process, you're getting more technical, and you're beginning to add information to those lists that contain specific information about how you're going to build your data model. So at this point, you're actually specifically looking at whether you're, say, going to build an Esri geodatabase or perhaps some sort of software, because you're capturing specific information about the end implementation. And lastly, the physical data model. This is the schema. This is your data model actually implemented inside of some sort of database system. So whether it's an SDE geodatabase or perhaps an Oracle database using Spatial plugin, it's the specific database with your model implemented inside of it. That's your physical model. It's the drawer divider, the actual physical drawer divider that can hold data. So those are 3 different steps, and I went through them quickly, but there's a lot of work involved there. There's lots of talking and writing down and collecting information. So how can we make that easier? Essentially, there are models out in industry that you can use as starting points. These are specific types of models that are out in the industry for pipelines. Although if you look around, there are models out in the industry that handle environmental, land, and other types of data also. PODS is very common in the industry, pipeline industry. PODS is a standard. They intend you take the PODS model and implement it as is, everything, hundreds of tables, and then add to it. The APDM is a slightly different methodology. Essentially, it's a template with some core data tables and some core data modeling processes, or standards. I shouldn't say standards. Techniques, kind of rules that are applied inside the APDM. And then operators can add or subtract to that as they see fit. So the APDM is a template. Started out in 2001 with version 1, and now they're at version 5. The different versions have added to and subtracted to from the core, and they have changed and improved the processes or the ways the data are organized inside the model. They become more streamlined and easier to update. So what is the APDM? How do you get it? You essentially go to the APDM's website, apdm.net, and you can download a bunch of stuff. You can download models that are in Visio UML and Universal Modeling Language? I don't have it. Markup language. Thanks. These are in Visio files, so you can, if you buy Microsoft Visio, you can open up these files and you can manipulate the data model inside of Visio. This is a case modeling tool, computer-aided software engineering. And what it does is it makes it much easier to build your model, update it, and maintain it than if you were to say just go into ArcCatalog and just type continuously in ArcCatalog. You can also download posters, white papers, and change logs about the model. And you can download XML versions of the model. In an ESRI environment, you can take that XML, open up an ArcCatalog, and you can spit it directly into a geodatabase, whether that's a personal file or a SDE geodatabase. And those are the templates, either the core or the full versions of the model. In an actual implementation, you wouldn't actually do that. You would start out with the UML, you would customize it to your organization, because that's the gist behind the APDM is it's a template. It's not just something you take and download and start running with. You take it, you look at it, you look at your organization, You figure how to make those two things work together, update your model, make your model fit your organization, and then continue going. When you download the model, you get abstract classes, core classes, and additional classes. Abstract is in yellow here because that's the real power, I feel, behind the APDM. You can take abstract classes, and they define templates for all different types of classes. Perhaps you've got something you want to model inside your organization that's not inside the APDM at all. You have a specific way you want to model it to make your to fit your organization, rather than vice versa. You don't want to change your organization to make it fit the data model. It's very hard to change people. It's much easier to change the data model. You model the feature based on the abstract class to fit your organization, and then your organization can take its data, put it in the APDM in your custom feature class or object class based on that abstract, and it works perfectly well inside the APDM. And essentially, the APDM starts as a starting point for logical modeling. You need to do your conceptual modeling first to make sure that you know what your organization needs, and then you take that list and you start putting it into the APDM. Some of those things are already going to be inside the APDM. If you look at the additional classes, there's already a feature class in there for pipe segment. That's the physical characteristics of your pipe segment. There's a class in there for valves. But perhaps your organization wants other things to go on top of pipe segment and valves. You can put that on top of those existing feature classes. Add your own fields, and voila, you've got your pipe segment. Not somebody else's pipe segment, but your organization's pipe segment. Okay, so I already kind of began this subject here. The next step is essentially updating the template to meet your organization. So that's simplified both the logical and the physical modeling. And you use case tools like Visio to help you do that. So it's systematic. The core attributes in almost every table inside the APDM have some core attributes so that there's standardization across all these tables. You're going to store certain pieces of information on lots of your feature classes, especially like the audit classes that kind of track what data is and where it came from and what its vintage is. Then there's also standardization between, say, types of features. T's, elbows, reducers, those are all types of fittings. You can imagine that they're going to have some similar base characteristics that are going to be stored similar on those multiple feature classes. Doing this inside a case, inside a UML, makes those processes a lot easier. So I mentioned these core classes. Core classes are the minimum common data that you need inside your geodatabase to make it an APDM. These essentially define how data is stored and referenced on the system. All the data inside the APDM that's on the pipeline, that's on the center line anyways, is stored essentially with linear referencing. It's using the stationing language that pipeline engineers are accustomed to using. And the core classes implement how that center line is defined and how stationing is defined, or linear referencing is defined on that center line. Then some other classes like subsystem range, product, site, activity, they define portions of the system, what you're being transported in the system, whether it's gas or oil or other products. Site defines locations around the system, besides just where the pipelines go to, or how the pipelines run, but where they get to. Compressor stations, valve stations, well sites. Activities. Activities are things that you do with your pipeline. There might be inspections, repair jobs, construction projects. So in addition to these core classes that you need to have, the APDM has additional classes. So these are template classes that the APDM has put inside the model that store what most pipeline operators have. Most people have pipe segments. Most people have valves to stop the gas or liquids from going from different places. Inspections range. So these might be hydro tests. No, not hydro tests. It might be smart pig runs. They might be ECDA, DIGS, CIS. These are all acronyms. Everybody loves acronyms. You can't be in GIS if you don't like acronyms. Leak points, places where you've discovered a leak and repaired it. Line crossing features, where your pipeline crosses other things. Other people's pipelines, other people's utilities, roads or highways, even streams. DOT class, another example, that's inside the APDM. So this is a common type of analysis that pipeline operators are going to have to maintain, or perform the analysis and store the results of it so they can define how they operate their system. All right, so to summarize the first part of the presentation that I've been covering before we hand off to Amy. You're going to do your conceptual modeling. Then you're going to choose to extend your core classes inside the APDM based on your conceptual model. You may decide to implement, extend, or delete the additional classes. So those are those templates that are provided. Or you may have something that's in your organization that you don't really like the way that it's defined inside the APDM, or there's no analog inside the APDM already. You find the appropriate abstract class that defines the basis for that class that you want to add, and you expand it out. So the abstract classes may be something like an online feature or an online facility, an offline feature, offline facility, offline point or offline polygon. These are essentially the basis, the template for adding additional types of attributes on top of to create a specific type feature that's appropriate to your specific organization. All right, so with that done, I'll hand off to Amy, and Amy can continue.
Thank you, Dave. Dave knows how much I love to present, so he asked me if I would talk a little bit about National Fuels APDM implementation, and I said, sure, I'd love to.
You'll do fine.
So I just have a few slides that talk more specifically about National Fuels implementation of APDM. And we began our data model search in 2005. It doesn't seem like it was that long ago, but it was. Integrity management compliance was really the primary driver of our going out and beginning to look for a data model. Like many operators, we had silos of data that needed to be integrated in order to comply with these new regulations, and we knew that we couldn't do it without getting everything into one system. So we had a lot of issues to address, and there's a few of them here. Multiple data formats and reference systems were really a problem for us. We had duplicate data stored in different locations. So we had a frame AMFM mapping system. We had multiple access databases for our risk assessment, for reporting, assessment data, like I said. We had Excel files for public awareness data and programs. And we had Esri personal geodatabases that we were using for our integrity management compliance in our DOT studies and HCA studies. So we had a lot of data that was stored in different places, and it was all being managed by various departments within the organization. And we knew that it wasn't working very well, and we were going to have a hard time at the end of the year trying to pull all of this data together for our PHMSA DOT annual reports. So all of this was kind of causing it to be a labor-intensive process, and we really struggled with quality control of the data because it was in so many different locations. These were some of the considerations we had as we started to search for our data model. We spent a lot of time looking at our data requirements and designing those, and also our functionality. We had hours and hours, many meetings, trying to decide what this should be. And as Dave mentioned, this is a key component in data modeling, and we spent a lot of time doing that. So we diagrammed our existing workflows and our processes, and we used Visio to do that. So we saw throughout the entire organization all of our workflows that we wanted to be able to model. We knew at this time that we wanted an open data model that we would be able to modify to fit our business needs and our existing workflows, not something that we had to change our workflows for. We also looked at our existing infrastructure and our other data management systems to try and figure out how those could be integrated as well. And we were using ArcGIS software at the time, and we knew we wanted to continue. So some of the advantages that we saw with APDM over other data models was just the flexibility to meet our business requirements. It allowed, the business actually dictates the model versus the model dictating the business, and we knew that was important to us. It had to be open, and it had to be able to be customized to meet our business requirements. We liked that there was no custom code, or there wasn't an intensive development effort, and it was tailored to our selected ArcGIS platform already. And we're also able to work with multiple Esri business partners and continue working with them. This is a slide that just shows what we're supporting with the APDM database now. And these were all pieces that had been disjointed and were in different types of Access databases or Excel files. So most importantly, all of our pipeline replacement projects and expansion projects are being loaded into our APDM database. Our classification in HCA and regulated gathering analysis has also been loaded into our APDM. We have a tool that we've designed using Model Builder for our risk assessment and analysis. And we also have a reporting tool that's built through Model Builder that then is able to take all of this data and intersect and overlay multiple different types of data to export for our PHMSA DOT reports at the end of the year. That might be my favorite thing. So just real quickly, I have 2 slides on lessons learned. The first one being, and probably the most important, don't over-design your data model. Sorry. Don't over-design your data model. We did that to some degree, and so now we're working through that. We're redesigning things because we thought we knew in 2005 what they should be, and now here we are in 2013, we're realizing our processes have changed, or maybe we just didn't design it properly in the beginning. Maybe we didn't have the right folks in the room at the time. So questions to ask are, do we have the data now? Do we need the data now? If yes to either, then we need to ask, who's going to maintain it and who's going to pay for it? And if the answer to any of those questions is no, then the data at this point in time is not required to be designed or in your data model. And my last slide, the second thing we learned is you need to prepare for your data model maintenance. It can be labor intensive, especially if you over-design your model, and time consuming and expensive if you rely on outside sources to help you with your data modeling. And number 3, just use all available resources when you're designing the model. Talk with other operators who have gone through an APDM implementation, and work closely with Esri and your other Esri business partners. So I don't think we have much time for questions. So if you would like to talk more about data modeling, please come find Dave or myself this afternoon. Thank you.